let's talk about composite figures and their perimeter. So we're going to talk about estimating paper and pencil versions, estimating stuff on grids is the same thing as paper and pencil versions, and then we're going to find perimeters of composite shapes. So first thing we want to do is take a look at the basic shapes. So if I have this basic shape, we're going to pretend this goes along the solid grid lines there, if you will. And this one covers 5 squares down, 4 squares across, 1 square there, 2 squares there, 3 squares there, 2, 1, and 8 squares here, I believe. 1, 2, 3, 4, 5, 6, 7, 8. Yes. And so the perimeter is just that distance all the way around. So we have 5 plus 4 is 9, 10, 12, 15, 17, 18, 26 is our perimeter of that shape. So the perimeter of that shape is 26 because we went all the way around, not crossing through it, not deviating away from it, but staying all the way around until we got back where we started. And it doesn't matter where we start. No matter where we start, we would end up with 26. If we started here and went around like this, we would still end up with 26 because that's the distance all the way around. So what if we have something where you can't find an exact distance for? So what if I had something like this, where this is all fine, so this is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, so that makes 10. But then what do we do here? Well, we're going to just use each diagonal is going to be approximately 1.5. And that's just an approximation. So we have 10, and then this makes 13 to here because it's 1.5 and 1.5. So 13, 14, 15, 16, 17, 18, 19. So that is approximately 19. So when you're doing perimeters of shapes that have diagonals like that, just count each diagonal piece as 1.5 units. That's an approximation. It's not the best, but it's going to do for now. So now, what if we have a shape that is a little, bit different? Let's say we have a square along with a circular edge. So have to kind of put this together. So if you can imagine, I've got this square with a circular edge, and this may be shown to you more like this, and they might even have a little dotted line here or something, but you're not quite sure how to do this. Well, if we find the perimeter, let's say we are given that this length over here is 12 meters, and then we want to find the perimeter. Well, we know that's 12, and that's 12. Well, how do we find this length along here? Well, that's our semicircle, so that's half of the area, the perimeter of that circle. So the radius of that circle is 6, And so we know c over 2 is equal to 2 pi r over 2. Oh, well, those 2's cancel. That's kind of nice. And so pi times the radius is just 6 pi. So the perimeter of this is 36 pi. No, it isn't. 36 plus 6 pi. I almost made that crucial mistake where I'm trying to combine the pi's and the not pi's. You have to really be careful. You can see even I almost made that mistake. Keep those ones that have pi in them separate from the ones that don't have pi. It's 36 from these three numbers, which don't include pi, plus that 6 pi, which does include pi. So we've got 36 plus 6 pi, and our answer cannot be simplified. That is it. Now, if we want an approximate answer, again, you can replace pi with either the calculator version of pi or 3.14 or 22/7 and find the approximate version of pi. Well, you could have all sorts of things like this, but what you need to do is just always make sure you're counting the outside. You're never measuring the inside. So be really careful. Like on this one here, we made sure that we did not include this piece right here because that is not on the outside, but we included all of the outside pieces. So be really careful about that.